The cost of producing X units of a particular product is given by this expression here, and each unit sells for $400. So we want an expression for the total revenue function. So R of X means that we've sold X items, and each item has sold for $400. So that's going to be 400X. Now for the profit function, we know that the profit is the revenue take away the cost. So that's going to be 400X take away X cubed minus 30X squared plus 320X plus 1000. So that's 400X minus X cubed plus 30X squared, take away 320X, take away 1000, and tidying that gives us 80X minus X cubed plus 30X squared minus 1000. Here we want the total profit for the 20th item sold. So if we evaluate P of 20, that's the profit on the first 20 items. So if we take away P of 19, then we're left with just the profit for the 20th item. So what we're going to have is this expression evaluated with X is 20. So that's going to be 80 times 20, take away 20 cubed, plus 30 times 20 squared, take away 1000. And we're going to subtract from that 80 times 19, take away 19 cubed, plus 30 times 19 squared, take away 1000. We should see here that these thousands are just going to cancel, so we don't need to actually put those in the calculator. And let's calculate. So we have 80 times 20, take away 20 cubed, add 30 times 20 squared, and we're going to subtract from that 80 times 19, take away 19 cubed, add 30 times 19 squared. Just check the calculation. Yep. And that gives me $109. Now we want an expression for the average cost of producing X items. So we know that the cost of producing X items is given by C of X. If we divide that by the number of items produced, then that will give us the average cost per item. So it's just going to be X cubed minus 30X squared plus 320X plus 1000 divided by X. We now want the marginal revenue, marginal cost, and marginal profit. Well, R dashed X is just got by differentiating this one, so that's going to be 400, so that's the cost per item. Then we want C dashed X, so that's going to be 3X squared, take away 60X, plus 320, and of course the 1000 disappears, just being a constant. And then P dashed X, is going to be 80. Take away 3x squared, add 60x, and of course the 1000 disappears. So we want to do p of 11, take away p of 10, a similar calculation to what we did here, so this must be the total profit for the 11th item sold. I could probably come over here and just edit this one. So the 20s we need to change into 11s. And that one there. And then going across here, these 19s, we need to change those into 10s. And then we can, so that's 379. So we now want p dashed of 10. So p dashed is this one here, so that's going to be 80. Take away 3 lots of 10 squared, add 60 times 10. So 80, take away 300, add 600, gives me 380. Now note, these values are very close to each other. Now this one here can be used as an estimate of the profit produced from the 11th item. So p dashed of 10 gives us an estimate of the profit on manufacturing and selling the 11th item. So it's always the next one up. Now, why is it an estimate? Well, it's a differential. So if we have a function that goes like this, doing this is exact. So the 10th item will be here, and the 11th item here. But because this is a differential, what it does is it goes along the tangent at this point. So it produces an estimate. It's not exact, but very often it's close. And there are situations where you would know the differential, the rate of change function, but not know the actual function, and that's why it's useful.